Have you tried titration before? Have you tried doing titration? So maybe not because you're not familiar with it. Okay,
I
so anyhow.
think yes, once.
All right, good. So if you have tried titration before, yeah, it will be a very big advantage for you guys. Like, normally if you are doing face-to-face now, you are doing practical exam for titration because there is always titration in assessment for external exam. Like paper 3, there's always titration with it. Anyway, so okay, so just a few reminders, everybody, on what are the apparatus that you can use that we are using for titration. So basically, pipette is needed, and then you have your dissection valve. We call it aspirator as well. Of course, the beaker, and then the burette. So this is the burette. I will discuss later on the uses of it. Everybody in A-level chemistry will remember that we call this Erlenmeyer flask as conical flask. So you would see the shape of it over here. Again, this is the conical flask, all right? What we have noticed last year in some grade 11 students, they are not familiar on the names of the apparatus. So these are the different glasswares that you can use. This one is known as the volumetric flask. So the volumetric flask basically has a very long, narrow tube over here before the base of it. Okay, so this is the volumetric flask. Again, the conical flask look like this. Of course, you know what is a beaker, right? And then this is now the measuring cylinder. So during exam, everybody, or during practical exam, remember conical flask, volumetric flask, beaker, and measuring cylinder are the glasswares that you are to use. Okay, so let's begin with titration. Okay, so some of you might ask, Mr. Ernesto, what exactly is the purpose of titration? And of course, how do we do titration? So yeah, this is the conical flask. So I hope that, yeah, you're familiar on how to use it, all right? And then we will also be doing some titration calculations for today, okay? So along the way, class, should you have any question, please do ask, all right? I need you to ask because I wouldn't know if it's clear or not if you will not ask, okay? Let's begin. So basically, the basic concept of titration, why is titration performed? So, all right, so let me use first my highlighter here so I can give emphasis on the important ones. Now, everybody, first I need you to remember that the most common use of titration, take note of this, is to determine the unknown concentration of a component. So we call that analyte in a solution by reacting it with a solution of another compound, and this is what we call titrant. Okay, so Mr. Ernesto, what does it mean? It means that, for example, this is always the case for every titration. So let's say, for example, you have here your substance A. Okay, substance A. We don't know the concentration of it. Okay, so if this is the concentration or this is the unknown concentration, then basically this is what we call as analyte. Okay, so we have substance A, and then so again, the main goal of titration is to determine the concentration of this. So basically, we don't know the concentration of this using another solution from another compound. So let's say we will use substance B. We know the concentration of substance B, okay? And then we know the nature of it. And then this one is what we call titrant. All right. So basically, using the titrant, we are to determine the concentration of the analyte. Okay. So the unknown, we call it analyte. Okay. And then the known substance, we call it titrant. Okay. So you'll be able to understand more of this as I go on with my animations. All right. So how to do titration. So everybody, you are seeing now here pictures of it. So yeah, that's the burette that you are seeing over here, the long tube over there. This is the conical flask. Again, some students are getting confused how a conical flask looks like. All right, so let's do. Okay, I will no longer play this video. Okay, I will be using first my slide in the animation, and then if you still have question, yeah, we can actually play this one because this is a little bit long. All right, so everybody, please look at the animation. I will be working now on how to use or how to do titration. Okay, so first, again, titration is a method of determining the concentration of a solution. Again, which substance are we, is the unknown, analyte or titrant?
Titrant.
Unknown. So the one that we don't know. So basically, the unknown solution, the unknown concentration, remember this one, we call it as analyte. Okay, so that is now the unknown concentration. So we want to know what is the concentration of the analyte. And what will we use? We will use the titrant. So basically, the titrant is the known concentration. Okay, so this one is known concentration. All right, so let's begin. Everybody, kindly look at this. Okay, so what will happen first? So let's say okay, I will pause it for a while. So let's say, for example, 25 cm cube of the alkali solution of known concentration is pipetted in the conical flask. Okay, so in that case, it tells you now that in this case, we know the concentration of it, of known concentration, okay, is pipetted in the conical flask. All right, so again, what is the volume? 25 ml. So let's do this. So I will click here so that we can get the 25 ml. So basically, you get the sample first from the beaker, and then we place it in a conical flask. All right, so the first thing, you have to place your sample in the conical flask. Okay, so after doing that, so the pipette should be rinsed with water and then with small amount of the alkali. All right, so this is the base. This is the base that we need. Okay, afterwards, look at this. Okay, so what will happen now is that the burette is rinsed with water and then we add now the acid. Okay, so we are now placing the acid over here. And then, so basically, it tells you now that we will try to get the concentration of the acid because we already know the concentration of the base. It tells you that it is known concentration, right? So let's do this. Okay, everybody, in external exam, I need you to remember that, okay, maybe I can have a little bit of it. So, okay, now, during practical exam, actually when you're doing titration all the time, you have to remember that the substance that you will place in the burette should start in 0. Okay, so the initial reading should always be 0 cm cube. Okay, this is very important. Okay, so what is happening now? Let's have a revision. So basically, you place your sample in a conical flask, right? How much did we place in here? What's the volume? 25 cm cube of base. Okay, so maybe I just write base in here. All right. And then in the burette, we place acid. Okay, so in the burette, so maybe I can draw it somewhere here. All right, so in this burette, you place here an acid. Okay, so you have base here. Remember, it's 25 cm cube. All right, now let's do this. So basically, we need to know the concentration of the solution. So maybe I can show it to you now. All right, so what will happen is this. So basically, before you do any titration, the next thing that you have to remember, everyone, remember this, you need to place a few drops of indicator to the conical flask. So remember this, I have some students last year, they forgot to place indicator before titration. So you have here the base. I need you to remember 25 cm cube. You have the acid in the burette. Okay, you add the indicator in this conical flask. Okay, so what is the use of the indicator? You will see it later on. Okay, how will I add it? Okay, so I am now placing the indicator. So you would see, okay, there's a change of color already. All right, or sometimes there's no change if it's the acid. Okay, but this is just an example. Okay, so what will happen now is this. So first, you remember you have a base here and then the acid is here in this case. So we will now titrate it by opening the bulb. So you have to open this one and then the acid will start to move. Take note of that. Until such time, I hope that you've seen that. I will do it once more. Keep on adding acid until such time that there is a change in color. What makes the change in color possible? It's the indicator. So you would see now that from 0, you end up with 22 cm cube. All right, so that means the 25 cm base here, for you to end up or to neutralize it, to get the end point, how much acid has been used? 22 cm cube basically reacts with this base. Okay, so acid is added to the burette until the solution changes color. Look at this. This is the end point of the titration. So remember, in A-level chemistry, when we say end point of the titration, that is the point wherein the liquid or the solution changes its color. Okay, then the amount of acid used is noted. So let's say, for example, you keep on adding it, and then at 22, there is a change in color here. Then yeah, so that is now the volume that you have used. All right, look what will happen next. But of course, you need at least 3 trials. So you will do it once more. And then when you think that you're very near to 22, okay, then what you can do is that you need to add it droply. So drop by drop, drop, another drop, just to confirm. So the endpoint is the first permanent color change. Okay, that does not disappear on swirling the flask. So again, once that the flask changes its color, then you would know that you have reached the endpoint. Okay, so with that, what are the things that we have established? It means that 25 cm of your base will basically react, or you will reach the endpoint when you added 22 cm cube of the acid. Okay, so that's basically how titration works. All right, so any questions so far? Class? None? Okay. So no one is answering, so I don't know if it's a yes or a no. All right. So anyway, class, we will be giving you a link of a video in YouTube, which is really good that you can do during your free time. Okay. So, but I hope that the basic concepts of performing a titration is here. So again, you have a sample of unknown substance. So let's say 25 cm cube. We don't know the concentration of this. Then we will be using acid to know how much of the acid will react to that. We know the concentration of acid in this case. Okay. So everybody, let's go to the next one. Okay, will it work? Okay, so I think I have to. All right. Okay, now let's do some calculations, all right? So let's say, for example, kindly look at this, guys, please, all right? So I would like you to imagine that this is exactly what happened in our titration a while ago. Okay, so again, what happened there? We have a base, sodium solution base, 25 cm cube. So I would like you to imagine that this is the conical flask. We place here how much? 25 cm cube. Okay, we know the concentration. We know the volume, but we don't know the concentration of it. Right? So that's how it works. Now, is neutralized by 23.4 cm cube of 0.998 mole of HCl. So I would like you to imagine now that in the burette, okay, in the burette, you place the HCl. So you have here the acid. What is the concentration of the acid? 0.998. All right. So that is now the mole per dm cube. I will write it here, okay, that you can see. And what is the volume? So after the titration, like in the animation a while ago, you end up with 23.4 cm cube. All right. So you would see now that the 25 cm cube of the base basically reacts with 23.4 cm cube of the acid. We know the concentration of the acid. So the only problem now is what's the concentration of the base? All right. So how will you do this? Everybody, please take a look. I will show you the calculations for it one by one. The first thing that you need to do, okay, but I think I have, do I need to erase it? All right. I hope you're not distracted with it. Okay. First, we need to calculate the concentration of the number of moles of HCl. Okay. And how will you do that? Everybody knows how to calculate already the number of moles. So basically, if that is number of moles, you will have concentration times the volume. Okay. So you can just directly convert this to 0.025. Then you will end up with 0.0234. All right. So like if you will do it, so yeah, number of moles. Anyway, it's here already. The concentration is, we are talking about acid here. Okay. So maybe we'll erase this. Okay. So basically, you can do it something like this. What happened here? Okay, so like you can have moles of HCl is equal, the concentration is 0.998, something like that, times 0.025, right? You know how to convert this one to the MQ, giving you now 0.024, and this is now the number of moles of HCl. Okay, next. After doing that, you need to know the ratio. How will you know the ratio? This is very important. You need to know how to write the equation. So NaOH plus HCl will give you NaCl and water. Now, you would see here that basically you have here 1 NaOH, 1 HCl. So the ratio of NaOH and HCl is 1:1. Yeah, I think that's easy, right? So again, calculate the number of moles of the acid because you have the concentration and the volume. After getting the number of moles, get the ratio to NaOH because we don't know the concentration of NaOH. So if the ratio is 1:1, that means that the number of moles of NaOH is also 0.0234 because it tells you that the ratio is 1:1. So 1 mole of NaOH will react to 1 mole of HCl. So like 0.0234 moles of HCl, that's equivalent to 0.0234 moles of NaOH. Question so far? Class, do you have question?
No.
None. Mr. Assylbek already gave you the link. Yeah, you can watch it later on. Question, Kairat, do you have?
No, I said no question.
No question yet? All right, thank you, Kairat. Okay, so with that, you are now in the number of moles. So I think this is very easy for you guys. You have the number of moles of NaOH. Remember, you have the volume of NaOH. So that means you have the number of moles, 0.0234. And then the volume again is how much? 25 cm cube. Do me a favor, calculate now. What is the concentration of NaOH? User calcu, everybody. Number of moles, 0.234.
Titration is 0.94.
Okay, answer is 0.94. Let's check. Very good. So the answer now is 0.094. So this is now the concentration of the base. So remember, you have your conical flask, right? You have your the 25 cm cube. We don't know the concentration of it. So by doing this process, you end up now with the concentration of the base, which is 0.936. All right. So that's also how it goes. Let's say we will reverse. We will place the acid in the conical flask and then the base is in the burette. The same procedure in calculating it. Okay. So let's do more practice with this one. Okay. So please hold your calculator, everybody. Help me out with the calculation. Oh my God, the time flies so fast. I only have 3 minutes. Okay. So there's a video there's a link of the video for YouTube in the chat box. During your free time, please do watch it. Okay. It will actually help you to revise as well. Okay. So let's do this. Okay. I will help you out with this one first, okay? But I need you to work with me. So we will do some calculations over here because I cannot write in the animation page. Calculate the concentration of sodium hydroxide solution if 25 cm cube is neutralized by 26.75. So you have here the volume of the acid, concentration of the acid. And then you have here the equation. Maybe you can try this. Everybody, please try it first. Write your answer in the chat box. Then I will discuss how to arrive with the correct one. Do it now. But I only have 2 minutes. So what is the first thing that I will do?
We need to number of moles.
Very good. Thank you so much. So let's get the number of moles of HCl because we know the concentration and the volume. Kairat, can you calculate that for me? What's the number of moles of HCl? So concentrate.
6.7.
Sorry?
6.7 times 10 power to the -3.
Can you confirm, everybody, if we have the same answer? So basically, that would be 250, okay, times, let me do it as well. So 0.250 multiplied by 0.026, 0.02675. All right, yes, that's correct. So everybody, I hope everybody knows how to calculate the number of moles there. All right, so after doing that, you would notice that the ratio is, let's look at this. So sodium hydroxide and HCl, so that is 1:1. Okay, so if this is 6.7 number of moles of HCl, so the number of moles of NaOH is basically the same. 6.67 times 10 to negative 3, right? Yes. Now, the volume is 25. So the volume is 25 cm cube. Okay, calculate now. Everybody, I need to see in the chat box. What's the concentration of the solution? Or maybe someone can give me the answer. Gulshaiza, thank you. Adina as well. I am seeing your answer. So the answer is 0.268. Meruwer, thank you as well. And Igarim. All right. So yes, the answer is 0.0268. And how will you do that? As simple as this. So basically, the number of moles is 6.67 times 10 to negative 3. Divide that one by 0.025 dm cube. All right. And you should end up with 0.268. Altinay Nazgul has also the answer. Thank you so much. So yes, that's correct. So the answer is 0.0268. Oh my, so it's already 11:30. I am trying to discuss it as fast as possible, but again, the time is faster than me. All right, anyway. Class, I will be uploading this PowerPoint for you guys. You can work with question 2, 3, 4.